Hi, everyone, and thank you, Kimberly, for hosting us, and thanks, everyone, for coming. My name is Miki Tebeka. I'm a developer for about 25 years, running my own training and consulting company. And during the last years, I started doing quizzes for programmers. So we're going to do one now. I'll show you a short Go program. You will have 30 seconds to guess the output. Possible answers are usually some kind of an output, so it's going to print something, or it won't compile at all, or it is going to panic, or maybe a deadlock. There are 21 questions in total, and I have unshamefully stolen some from Dave Cheney, Brad Fitzpatrick, and other who posted them on Twitter as a Golang pop quiz. And the question is why? Why do we do that? And as I said, I'm teaching a lot, and I found out that people really like these quizzes and puzzles. It's challenged their thinking. It helps them gain better understanding of the language and what they're doing, and it's fun. So we usually in our day-to-day work solve puzzles for a living, right? Coding is basically how can I do that? There's also a lot of research showing that people who make mistakes during the learning process learn better, and a lot of these quizzes are exactly for that. So they might seem innocent. I sneak some when I also teach in classes. So I'll try and start writing code, intentionally making something go bad, and hopefully people will catch it. And it's always a good, fun experience. So let's start. First one. Okay, so if you're going to run it, this is going to print 0.25. And when you look at this thing, it's like, why is that? And the thing is, this is actually a floating point number in Go. And if you go and read the language specification, which is great if you're having trouble sleeping, you will see that they define here. This is a format with hexadecimal number, an exponent, and it's valid. So I don't think I've used it anywhere, but just knowing that this thing happens prompted me to look at other number types and ways to represent numbers in Go. And there are several ways to do that. Some of them are even really useful. Right, so this is going to print 0, and even though M is nil, it's not an uninitialized map, when you access a map with a missing key, you are going to get the 0 value for the mapped values, which in this case is an integer, so you're going to get a 0. It's not going to crash like you might expect. So you can do like Colin and also post your guess. This is totally fine. I've been to Krakow a couple of times for teaching classes. It's a great city, and it's an awesome for teaching about Unicode. So two things happen here. One is that the %t verb in the printf is printing the type of the variable. And the second thing is that when you access a string in Go in square brackets, you are going to get bytes. And a byte, even though there is a specific type called byte in Go, it is an alias to unsigned int 8, which is what we see here. So this one is going to deadlock. All Go routines are asleep. It's a deadlock. And the reason is, even though you do a t.stop on line 11, it does not close the channel. So when you do a for range on a channel, you need someone to close the channel for the for to terminate. This for is not terminating, and we get into a deadlock. So 7. Even though we have 6 characters, in the Go strings, there are UTF-8 encoded, but they have this duality. On one hand, you can look at them as a string with Unicode code points, and then there are 6 Unicode code points, but on the other hand, you can look at them as a slice of bytes, and this is what's happening here when you do len. And the O with the omelet on the top is 2 bytes. This is UTF-8 for you, or Unicode in general is fun, right? Right, so we're going to get 1, 3, and 4. And what's usually puzzling here is that the colon equal is usually used for assigning and creating a new variable, and B is not a new variable. But the colon equal works even if you have just a single new variable on the left side, it is still good. And this is going to panic. And this is, if you remember the previous one, we just tried to access a key and then we got 0. Now we're trying to change the map. The map is still nil. We hadn't used make to create it. So this time it's going to panic. So some operations on maps like len and getting keys are nil safe, and some like these are not nil safe. So this is going to print in 32. So in Go, the character type is known as a rune, and there is a type called rune. But run is again like byte, which is an alias to unsigned int 8. Run is an alias to int32. So this is not going to compile. This is an invalid operation. And the thing is that once we do this line 9, which is timeout equal 3, Go is doing type inference and saying that now timeout is an integer. And now we multiply an integer by time.millisecond, which is of type time.duration. So these are two different types, and the Go compiler does not allow them. Okay, so this is going to print 8. And the reason is that this operator, it's not the power operator, this is the XOR operator. So exclusive OR. And there is no power operator in Go. Okay, and this is going to print 199 and 3. B is a copy of the slice S, but they are both looking at the same underlying memory. So every change we make to S is going to be reflected in B as well. Slices seem simple, but they can be sometimes really tricky. So this is going to print A and B. And the fact is that we have the same function twice with the same name. But in it is a special function in Go. It is called by the runtime before main starts. And you can have several of these in the same file, as counterintuitive as it seems. And this is going to print 2, 2, and 2. And here you see that, like, unlike the other place, I did convert n to time.duration. So now this is working. The compiler won't complain about that. The problem is here. When we look at this n is same for all the Go routines because it's coming from this line 11. So this is known, we say that n comes from the closure, like this. And this is a common problem. Most IDEs today will highlight this as a problem, as a problematic issues, and let you know about it. So this prints out an approximation of pi. And there are two interesting things here. One is that we can use a Greek letter as an identifier or a variable name in Go, and Go supports Unicode also in variable names. The second one is that we managed to divide 355, which we think of as an integer, by 113.0, which we think of as a float, and usually the Go compiler will not allow that. But the case here is that 355 and 113 are constants. They are verbatim in the code, and constants in Go, they're given type when you use them, not when you create them. So the Go compiler makes both of them float. Right, so this is similar to the previous case, but a bit different. The difference is this command, this line, and in this line we do s append s4. What happens here is that when you do an append, the append function sees that there's not enough space in the underlying array of s, and it creates a new underlying array for s and copies the original one. B is still pointing to the old one, so any change we do from this line on is not going to be reflected in B. So this is going to print 4Cs, and what is usually not common is this range of 4. We usually have some kind of variable for something equal range, but you could do just 4 range, meaning do n times the length of a string. So the length of a string is 4, so we get 4Cs. And this is going to print 2. Right, so we create a buffer channel with a buffer of 2. We put 2 values inside the channel. We get 1 value out of the channel. Now we close the channel. And even though the channel is closed, when you do receive from the channel for the second time, you will still get the value that was in the channel, even though it was closed. So we're going to see 97. The percent v verb is to print any value of Go. Depending on the type, it will print something. The type of name one is a byte, which is like a number. So Go is going to print the number, which is representing the character A. And this is going to print 2, 1, and 0. So every time you call defer, it's like putting a function to be called on the stack. And then when the function exits, in this case, the main function, these are going to be popped from the stack. So last in, first out. So first we're going to print the 2, then the 1, and then the 0. And usually don't do defers in a for loop. That's not the right idea. Right, so this is going to print A, backslash T, and B. When we start a string with backticks, this is known as a raw string, and backslash is just a backslash. Last one. So this is going to print 121 and then a lot of zeros and then 2. And this is not a bug in Go. This is how floating points work. Any language you do it, it will do the same result, including Go. This is how the floating point specifications work. So at the beginning, when I saw these quizzes, I failed a vast majority of them. So this is fine, but now it's a good idea to start learning. As Kimberly said, I have a book called Go Brain Teasers. On the cover now, you can explain this one. There I have more quizzes, and I also, some of them are different, and also the explanations there are deeper, and I also show a lot of reference to places where you can go and extend the reading about these topics in general. Some of them, like Unicode and floating points, are across languages, not just that. I also have Python brain teasers and pandas if you're interested. And that's it. Thank you very much, and thank you for codebar.
Okay, we've got a little bit of time for questions. So if anyone's got any, please do drop them in the chat.
You learn. So how do you recommend learning all of these? So most of these are bugs that I actually made, and that's how I learned about them. There is my book that you can read, and there's deeper explanation. But I think the idea is that every time you see something like that, don't just go to Stack Overflow, copy and paste some fix and go there, but try to understand what's happening behind the scenes and why is it working like that. And that's a great learning experience. And that's what I usually do. I do read the Go spec because I'm interested to find out why are these things happening. And I think it makes you a better developer at one point or another. Running programs, playing around with them, all of these, I try to distill them. Most of the stuff the bugs themselves are much more complicated. I'm trying to distill them to something which is good for teaching, but also for me for solving the bugs. I have this big program, something first. I try to replicate it in the smallest piece possible and then dig in as much as I can. I'm asking people and learning. I learned a lot about Unicode, floating points, time zones this way. So just be curious. Curiosity is the best way. Oh, the technology for this slideshow. This is a tool that is from the Go team. It's called Present. I hacked it a little bit just to have the timer on the right left side, but apart from that, it does it already for me. So I just install it. There is it's like a markdown format that you can write, and then it shows the slides. So I just added a little bit of JavaScript. Kimberly posted the link to the book on the top. Right, Kimberly? The beginning of the chat? Yeah, so it's there on the beginning of the chat. Oh, she did it again. Awesome. Thank you very much. It's not a website that I conduct training. You feel free to reach out to my email. I'm doing some live sessions, mostly in conjunction with the Alden Labs, if you know them. And I'm doing tailored workshops for companies. So we go and talk about the needs for the company, and then we build a workshop for the team that wants them, depending on the level, the topic of interests, and many more things. Looks like very good. Thank you very much.